Hi Flashes! So today we are going to be starting the probability unit. So with probability there are a lot of definitions that we need to know. So I have already written out the definitions for all of these vocabulary terms. So I will go through them, but just make sure that you get them down, so you may have to pause this video in order to write down all the different definitions. So the first one is what we call theoretical probability. So today's lesson is on theoretical and experimental probability. So theoretical probability is when the ratio of the number of equally likely outcomes in an event to the total of number of possible outcomes. So here in a second I'll talk about what is probability, but when we express probability, it's usually as a fraction. So when it says the ratio, that means the fraction. So your numerator is the number of equally likely outcomes in an event, and then your denominator is the number of total possible outcomes. The next definition is equally likely, so this means that outcomes that have the same probability. So for example, if I were to flip a coin, so as we know there's only two possible outcomes to a coin, and that's heads or tails. And let's say I spin a spinner that only has numbers 1 and 2 on it. Well, since the coin only has heads and tails, so 2 outcomes, and the spinner only has 2 outcomes, 1 and 2, they are going to have the same probability, so we will call that equally likely. And then fair is when each possible outcome of an experiment is equally likely. So it's also just called fair. Okay. Alright, so then, well, if we're talking about probability, what is probability? Probability is the likelihood of an event happening. And the thing that you guys need to know is all probabilities range from 0 to 1. You are never going to have a probability less than 0, and you're never going to have a probability more than 1. So it's super, super important that when we ask you guys, what's the probability of something happening, that your answer is somewhere between 0. So like I said earlier, probabilities can be expressed as fractions, and that's the one that we will be using the most. But as we know, you can change fractions to decimals and decimals to percent, so you could see probabilities as decimals and percents as well. Okay. Okay, so there is a probability line, okay, and like I said, probability ranges from 0 to 1. And within that probability line of 0 to 1, we have different words to help us understand how likely is something going to happen. Okay, so on the line, we start at 0. And if we have a probability of 0, that means that this is an impossible event. So for example, if I were to roll a die, so as we know, numbers on a die range from 1 through 6. If I said, what's the probability of rolling of 7, you guys would say, oh, there's not a 7 on a number cube. So that probability would be 0 because it's impossible to get a 7 on a number cube. Okay. Then as you work your way up, 0.25, or in other words, 1/4. If you have a probability of 1/4 or 0.25, that means that it's unlikely to happen. So it's not impossible because it's not 0, but it's also not likely because it's 0.25 away from 0. So it's still close to 0, and it's further away from 1, so that makes it unlikely. If you have a probability of 1/2, that means that you have an even chance. So like flipping a quarter, you can either get heads or tails. Okay, so it's a half and half situation that can happen, so it's an even chance of getting heads or tails. Then the next one's 0.75, or in other words, 3/4. This is close to 1, so it's going to be what we call likely. It's not certain that something's going to happen, but it's still very likely that something will occur if we have a probability of 0.75 or 3/4. Okay. And then the last one, probability of getting a 1, means that it's certain. So if I said, what's the probability of getting heads or tails on when I flip a quarter? Well, those are the only two options that can happen, is heads or tails. So that means that my probability is 1, because I know for sure that every time I flip a quarter, it will land on heads or tails. So that means that it's certain that it's going to happen. Okay. So you guys do need to know these for your test. So just make sure that you guys remember the probability line and where each of those terms fall. Okay. So let's look at some different examples so that you guys can use these words in some context, okay? So events could be described as impossible, unlikely, have an even chance of happening, likely, or certain. How likely do you think the following events are to occur? So the first one says, Thomas Jefferson, the 3rd President of the United States, will visit the College of William and Mary tomorrow. So it's impossible, unlikely, even chance, likely, or certain. So what's the possible outcome that could happen that Thomas Jefferson will visit the College of William and Mary tomorrow? Well, that's impossible because Thomas Jefferson is dead. Oh, sorry, my video froze. So it's impossible because Thomas Jefferson is dead. So he will not be visiting this college tomorrow because he's dead. So it's impossible that he will be there tomorrow. All right, second one, you will ride the bus home from school today. So there are 5 different outcomes: impossible, unlikely, even chance, likely, or certain. Okay. Now, a lot of students, when they see this question, they just want to think about themselves. So they're like, oh, I am riding the bus home from school today, so I'm picking certain. Or, oh, I'm not riding the bus home from school today, so I'm picking impossible. You have to think about it as if everybody were to read this question, what's the probability? So, like, if I were to go and ask Miss Collins if she's riding the bus home from school today, or if I were to go and ask a random student if they're riding the bus home from school today, you just have to think about it as that. So our answer is going to be even chance, because as most students, you're either riding the bus home or you are doing something else. Okay, so since you're doing one or the other, that's why your probability will be 1/2, which means that it would be an even chance. So same thing with number 3, school will be canceled tomorrow due to bad weather. Well, it's either school's going to be canceled tomorrow or school's not going to be canceled tomorrow. So since there's only that 2 options, that means that you have a 1/2 possibility of not going to school tomorrow. So again, that's going to be your even chance. All right, and then the last one, if you roll a standard die, it will show a number less than 7. Well, as we know, on a number cube, our numbers are 1, 2, 3, 4, 5, and 6. So if we want a number that is less than 7, aren't all of those numbers less than 7? Yeah, all of them are less than 7. So we know for certain that when we roll a die, we're going to get a number less than 7. So that is certain. Okay? So let's go ahead and move on to our next page and start talking more about theoretical probability and how to find probability from different examples, okay? So the first one says, Andy has 20 marbles in a bag. Of these, 9 are clear and 11 are blue. Find the probability of each event. Write your answer as a fraction, a decimal, and a percent, okay? So when we are finding the probability, you guys are going to start seeing capital P. Okay, so when you guys see capital P, that is just in short for probability. Okay, so when we find the probability, this is coming from the definition. You are taking the number of favorable outcomes over the total number of possible outcomes. So the total number of favorable outcomes over the total number of possible outcomes. So when they tell us to find the probability of getting a clear marble, this is what we are trying to figure out. So anytime they put probability of something in parentheses, whatever is in parentheses is our favorable outcome. So finding the probability of a clear marble, we need to count the total number of clear marbles over the total number of marbles altogether. So looking at our story problem up here, it says that there are 9 clear marbles. So if we are trying to find the probability of clear marbles, however many marbles there are, that is going to be our numerator in our fraction for our probability. So there's 9 clear marbles over how many marbles total? Well, there's 9 clear and 11 blue. So if you take 9 plus 11, that's going to give us 20. So there's 9 out of 20 clear marbles in the bag. And that's your probability, 9 out of 20. And then they do want us to change it to a decimal and a percent. So remember, to change a fraction to a decimal, all that you have to do is divide. So if you were to take 9 divided by 20, we get 0.45. And then to change this decimal to a percent, you just move your decimal point 2 times to the right, and that would give us 45%. So the theoretical probability of drawing a clear marble is 9 out of 20, 0.45, or 45%. Okay, so let's do another example. So there are 13 boys and 10 girls on the track team. The name of each team member is written on an index card. A card is drawn at random to choose a student to run a sprint, and the card is replaced in the stack. Find the theoretical probability of drawing a boy's name. Okay, so again, this means probability of drawing a boy's name. So in our numerator, we need the number of boys on the team, because whatever is in your parentheses, that is your number that's going to go in the numerator. And then on the bottom, it's always going to be the number of the total of whatever we're talking about. So this one is going to be the number of members on the team. So all boys and all girls. Okay. So finding the probability. So your numerator is how many boys are on the team. So looking right here, it says that there's 13 boys on the team. And then it's going to be over the total number of members on the team. So you have to include boys and girls. So if you were to take 13 plus 10, 13 plus 10 gives us 23. So there are 13 out of 23 members that are boys on the team, and that's your probability. Okay. Please note that you guys will have to reduce your fractions on your test. So out of the 2 problems that we just had, we did not have to reduce. But if it does show up on your guys' homework, just please remember that you guys have to reduce your fractions. Okay? Alright, so I want to do like one more example. So if I said, what's the probability of getting the numbers 2 or 4 on a number cube? Again, as we know, on a number cube, there's numbers 1, 2, 3, 4, 5, and 6. So if I said, what's the probability of getting a 2 or a 4? Well, how many 2's and 4's are on the number cube? There's 2, right? There's a 2 and a 4, so there's 2 or 4's. And then it's going to be out of how many numbers are on the number cube total. Well, there's 1, 2, 3, 4. 4, 5, and 6. So there's 6 numbers on the number cube. So your probability for getting a 2 or a 4 on a number cube is 2 out of 6. And then if you were to reduce that, it would be 1/3. Okay, or if I said, what's the probability of getting tails on a quarter? Well, as we know, the only 2 options are the only two options are heads or tails. So how many tails are on a quarter? 1. Out of how many possible outcomes? 2. So your probability is 1/2. Okay, so that's what we mean by theoretical probability. Theoretical probability means what's supposed to happen. So the actual probability of the likelihood that something will occur. Okay, because when we get to experimental probability, it's the probability of what happened in the experiment. Okay, so experimental probability is the ratio of the number of times an event occurs to the total number of trials. Okay, so theoretical probability is what's supposed to happen. Experimental probability is what happened in the experiment. Okay, and that's easy to remember because experiment is in the word experimental. Okay, so same thing. So during a skating practice, Sasha landed 7 out of 12 jumps. What's the experimental probability that she will land her next jump? So probability is taking the number of times an event occurs over the total number of trials. So this means that we just need to find the probability of how many she landed. So again, whatever is in that parentheses, that is the number that you need to put in your numerator. So if we are trying to find the probability of how many she landed, again, that's just the number of jumps landed. And then it's always going to be over the total. So it's going to be the number of jumps attempted. So let's find the probability. So how many jumps does she land? Well, it said that she landed 7. So our numerator is going to be 7 out of, and then how many jumps does she attempt? It says right there 12. So she landed 7 of the 12 jumps, so 7 out of 12 is your probability. So the experimental probability that Sasha will land her next jump is 7 out of 12. All right. Next one. Students have checked out 55 books from the library. Of these, 32 books are fiction. What's the experimental probability that the next book checked out will be fiction? So again, we're trying to find the probability of fiction. So whatever is in that parentheses is the number that's in your numerator. So it's the number of fiction books checked out over the total number of books. So looking at the context, how many fiction books were checked out? It says right there 32 books were fiction, so that's your numerator. And it will be over the total number of books that were checked out. So it says students checked out 55 books. So your probability is 32 out of 55. So the experimental probability that the next book checked out will be fiction is approximately 32 out of 55. So as we know, this with experimental probability, we know that this is just guesstimating. So just because we find the probability does not mean that that will be the actual probability that the next book checked out will be fiction. Okay, we are just approximating since this is a experiment, and we know that from experiments that it won't always be exact. Okay. All right, guys, and this last one. So students have checked out 55 books from the library. Of these, 32 books are fiction. So it's the same exact problem. However, they are wanting to know what's the experimental probability that the next book checked out will be nonfiction. So if you look at the context, they don't tell us how many books are nonfiction. They only tell us the number of books that are fiction. So what we're going to have to do is think, okay, so we know that 32 books are fiction, and they checked out 55 books total from the library. Well, we know that books are either fiction or nonfiction. So if 32 books were fiction, how could I figure out how many of them were nonfiction? Well, what if they told us that there were 55 books total, 32 of them are fiction? that means that the other ones are nonfiction. So I just need to figure out what is 55, so the total books, minus the fiction books that there are. And then this is going to tell me how many nonfiction books there are. So if I were to take 55 minus 32, that is going to give me 23 nonfiction books. Okay. So again, when you go to find your probability, the number of nonfiction books is your numerator. So we just found that, the number of nonfiction books, we just found that to be 23. So our numerator is going to be 23 over the total number of books. So our total number of books is 55. So the probability of nonfiction books is 23 out of 55. So the experimental probability that the next book checked out will be nonfiction is 23 out of 55. Okay, so that's it. That's probability. So just the main thing to remember from this lesson is, one, probability is a number that ranges from 0 to 1. We can look at probability from a number line and determine the likelihood that something will happen. So it ranges from impossible to certain. And the difference between theoretical and experimental probability is that theoretical probability is what's supposed to happen, and then experimental probability is what happened from the experiment. So sometimes it won't always be the exact probability like theoretical is supposed to be, but it's just what's the probability that happened from the experiment. Okay? So if you guys have any questions, just let your teachers know, and hope you guys have a great rest of your day.